Ancient civilizations tried to forecast the weather by observing cloud patterns or even using astrology. Today, we rely on instruments like the barometer or the barograph, which automatically records on paper variations in atmospheric pressure. High pressure indicates good weather, low pressure means bad weather is likely. This barograph has three main parts: the recording arm, the cells that react to atmospheric pressure, and a rotating drum. To make the drum's lid, a die press operator stamps out a 9-centimeter disc from a long strip of brass. He cleans off the grease from the die press and places the disc on another press to form an edge. To make the drum, he cuts a 10-centimeter long cylinder from a brass tube. Next, he places the drum on an arm that rotates at high speed. He etches fine lines into the brass using steel wool. Thanks to a handy rotating device, all the drums get an even coating of protective lacquer so the brass doesn't corrode. The barograph's mechanism rests on a solid brass plate that's 214 millimeters long by 125 millimeters wide. A worker greases each one, then places them on a press that punches out holes for the fastening screws. Next, he places the plate in a metal holder and buffs it with a rotating polishing brush. He applies wax to the brush to help achieve a perfect mirror finish. Now, workers use a fine grade of sandpaper to polish the solid brass arms that will hold the working parts in place. Then they line them up on a board and buff them with the polishing brush. How do they get those parts so shiny? By washing off any machine grease before polishing them. Putting the barograph together is precision work. Laid out before the assembler are all the working parts she will need. She begins with an arm, inserts a brass screw, then sets in a second arm and attaches them to the base plate. These hollow metal cells are the key to the mechanism. Air pressure makes them expand and contract. The barograph records this movement to measure high and low pressure systems. The cell stack is put in place on the base plate. Then they add the lever system that connects the recording arm to the paper. This lever system connects to the arm, raising and lowering it so the felt pen at the tip can record changing air pressure levels on the drum's rotating chart. The assembler inserts tiny pins to hold it together. Inside the drum's base is a battery-driven quartz clock, which maintains a steady rate of rotation. Now she wraps the chart around the drum and attaches a brass clip to hold it in place. The drum rotates once over a 7-day period, so slowly that the movement is invisible to the naked eye. There's a gear system inside the drum, which rotates it once it's set on the axle. A brass screw holds it in place. Now the worker puts the mechanism on a mahogany base. She screws it into place, then covers it with a glass and mahogany housing. Brass hinges and a closing mechanism hold the housing firmly in place and provide easy access. A quality controller places the barograph into a pressure-sealed chamber to check its accuracy. He compares the barograph's recordings to gauges outside the chamber that measure the changes in air pressure that he applies inside the chamber. This weekly chart shows hour-by-hour recordings of air pressure variations measured in hectopascals, a unit of atmospheric pressure. Barographs are available in a variety of designs, from modern to traditional brass and mahogany models that any sailor would be proud to own.